because I'm forgetful. It's nice to see everyone here for our AI club here at LCC. This week, we're going to work through several different things together. First and foremost, I want to see if any of you, remember we ended last week where people were going to try and find some data sets that you were interested in. Did anyone do that? It's okay if you didn't. I've got another resource I'm going to share today. But has anyone found that data set that you're excited about, the one that you want to work with for a while and actually do some meaningful analyses?
I didn't select one, but I just happened to be searching through Kaggle, and I seen one about the 2021 Olympics. It was seemed like that was interesting.
Hey, James, Olympics. I was enthralled with the Olympics it's past summer, and yeah, that could be some great data. Anyone else? I like the Olympics. That's actually probably got some neat stuff we could pull out of that. No one else? All right. Well, I'm going to show some more resources this week, and maybe you'll find that diamond in the rough there. Oh, and Dell mentions data breaches on Reddit. Yeah, actually, Reddit is one of the resources that I've got in a list here that I would point out is very good. So let's have a look at a few things. I'll share my screen here. Let me get set up. I wanted to talk about a new algorithm, something else, another tool in our belt that we can use from a machine learning perspective. So let me share my screen. And so hopefully you can see this. Let me, I can make that a little bit bigger. How's that? Can you read that okay? Now, I want to talk about KNN, nearest neighbor algorithms. So K nearest neighbors. When you think of that name, the good news is semantically, it's actually going to help you remember what it's actually doing. I've got some stuff open here that'll let us play around with this in some ways, but we can use this KNN, K nearest neighbors, as we see here. We can use it for classification, but don't let this little snippet fool you. We can essentially use this. It's very similar. We can use something called KNN regression to actually not just classify things, but we could also use it to make predictions about values. It's a very cool tool. Now, it's not perfect. We're going to talk about some of its pros and cons, but you recall we just briefly talked about decision trees. And I just want to expose you to another type of model that we could use. Now, this says, let's just go through this fact, why this, although it's simple, they call it a lazy algorithm. This is opposed to eager algorithms. Think of an eager algorithm. It goes through everything and it says, I'm going to look at all the stuff first and I'm going to create a model, and then you'll just be able to plug it into the model, and whenever you want your prediction, it's there. KNN says you give KNN a data set and it's like, I'm done. It doesn't do anything at runtime. You in terms of initially getting the training data, you give it the training data, it says, cool, I'll use that when I'm ready. It doesn't do anything. Then when you want to find a solution, it says, okay, now I'm going to look at this training data. I've memorized the training data, and I'm going to do some figuring out to see what I would give as my solution. It does all of that work later when you actually need the answer. So you have eager algorithms where they do the work up front. And then anytime you want a new prediction, you just plug it into the model and it just spits it out. They're a little bit more efficient once they have the model. It just takes some time to build the model. With the lazy, like a KNN, it's like, give me the data. I'll worry about it when it's time. Come on, I've got it. I got it. Don't bother me. And then you say, hey, can you give me a prediction for this? And it says, okay, I'm going to do my work now. And it looks at the training data, and we're going to see how we can use training data to make a prediction. But it is what it says it is, nearest neighbors. We go by the nearest neighbors to make our predictions of any new neighbors. So let's see what I'm talking about here. First, you can always go to Wikipedia and take a look around, but it's very easy to be intimidated if you start to scroll down and look at the math there. Don't get lost in that. It's not as complex as it looks. Don't let that prevent you from enjoying the beauty of this algorithm. Notice here, though, it does make the distinction. We have classification capabilities. And we can also perform regression. Remember, classification, which class would something belong to? And regression, make a prediction, for instance, what would be the predicted sale price for a particular home if you know the number of rooms and the year was built and any number of other particular attributes. Now, when we use this and we have everything already labeled, it's a supervised algorithm. And remember, that just means we have labels, and then we're going to use those labels for training purposes, and then we'll use this algorithm to come up with another prediction for other data that we have access to. So let's work past this. This is very intimidating. Let's go just play around with it. I'm going to put this link in our chat. Now, this is a neat little online interactive demo that lets us look at how this behaves. I'm going to reload this just so it's now. K, when we talk about a K nearest neighbor, K is just how many neighbors do you want to consider when you're making a prediction about something, some new data point that you don't have labeled. So don't worry about the metrics over here right now, the L1, L2. Don't worry about that right now. You can choose one or the other. Subtle differences here. Don't sweat it. Do look at number of num neighbors, K. If we're looking at one neighbor, we're looking at the closest neighbor for any particular point. So let's say I'm looking at this one right here. I'm going to move it a little bit. Notice when I move it, it changes the boundary. I hope some of you are playing with this on your own computers. What happens is we look at that one point and then we say, what's its nearest neighbor? And what Okay, can you still hear me now? Did you?
Yes.
It totally, I don't know if you saw that, but it totally was crashing on me. So let me try this again. What was the last part you heard?
I hope some of you are trying this.
On your own computer, yeah.
Okay. Well, you would know I compliment Zoom and how nice it was working relative to WebEx, and then it crashes on me. That's how things go. But let me share my screen again. That's just the irony is not lost on me. So let's try this again. But notice when we move, I'm gonna not annotate anything right now. I'm just going to move points around on my screen. Notice what it would do is it would now say, what's the nearest neighbor to this particular point? And then it will, as I move points around for the classes, it's drawing new boundaries. It's saying anything, because I moved this point and we know it's a, let's call these Lions fans because it's blue. If I move this around, because this is over in this space, if there was a new point, I will annotate, I lied, we're gonna risk it. I'm living dangerously. That was right here. It would be chunked in with the Lions fans. Because we do nearest neighbor and this one now wins for this, because this point was moved around. Now, if I move it back this way though, now the nearest neighbor would be this one. And so now this would be called, you know, what's purple? So this is a Ravens. So this is Lions, that's Ravens. Baltimore Ravens. This would be Green Bay. Packer fan. And the lowly San Francisco 49ers. So notice we're using, you're better off saying the Vikings. I could have used Vikings, sure. Sure, but for whatever reason, I just watched Baltimore play, so I was thinking of them. Now, notice, again, we have K is 1. That means we only care about one neighbor to make our decision. But now let's change it to 2. Whoa. Now you need 2 points. You need to take the 2 closest points to make a determination. Well, you can see there's now a lot of white on the screen. We now have a lot of ties. We don't like ties. Ties. So for instance, if there's a tie between this point and this point, so let me annotate them. If there's a tie between this one and this one, we have no, like, we don't know what to say. We wouldn't know whether to classify this as a Lions fan or as a Ravens fan. We typically, that's why we typically choose odd numbers. You have far fewer ties. You always want to be able to break a tie, and that limits the boundaries that we don't really have a good answer for. So K and N, we'd go by 1 neighbor. See what it looks like there. We'd go by 3 neighbors. We could go by 5 neighbors. We could go by 7 neighbors to make our classifications. Notice once you get 1, makes a pretty big jump to 3. But then once you get to 3, a more subtle jump to 5. The jumps between 5 and 7, not that big, at least the way I'm looking at it on my screen. So what we see is you're going to probably find a sweet spot given your particular data, how many neighbors you'll want to use to determine which class it belongs to. So again, if it's looking at KNN 3, if I had a new point that was, let's give an example, that was right here, if that's the new point, then I would look at the 3 nearest. So that I would look at this one, I would look at this one, and let's say I look at this one. Well, because 2 of those are Lions fans, then we're going to say this one is likely a Lions fan too. Does this make sense? Is this generally, you get the general concept here in terms of using this to make a prediction? It's called KNN, K nearest neighbors. This right now, we're doing classification. Are you a San Fran, Green Bay Ravens or Lions fan? By the way, I just want to say, I like the Lions coach. The Lions have not had a great season in terms of record so far, but I like the coach. I like the intensity and the passion the person has for football. You got to, at a certain point, you can't just keep swapping out the coaches. I hope they stick with him and give him a chance to make a change. So we'll see what happens. All right, I digress. Doses throw the team away. Look, a lot of their losses were by less than a score. You know, like many less than 3 points. Those last second field goals. Come on, that's tough. Oh, I got new. Here we go. Someone else entered. Hey, we're just talking through K nearest neighbors. And I'm recording, so you'll be able to go back and see this, but it's a different type of algorithm we can use. In this case, walking through, let me clear all the annotation here. In this case, we were just playing around with the ability to use different neighbors. A KNN is just where we look at the neighbors and make a prediction according to which neighbors you live closest to, given some type of data, some other type of attribute. So in this case, I see Dell says loss is a loss. Dell, not all losses are the same. A loss by 50 is not the same as losing by a last second field goal. I see improvement. So Stafford's doing very well, but Stafford went to the Rams, had a lot of talent there. We could do an analysis there too in terms of AI. Did someone want to say something? I heard a microphone. Go ahead, speak up if you've got. For those who just came in, I just want to share this link again in the chat so you could play around with this while I'm talking. But we were just talking about a new algorithm for us, KNN, K nearest neighbor. And essentially, you just look, if I draw a new point on here, if I draw the point here, because it says 1 for K, that says how many neighbors do we want to use to make our comparison? I'm looking at 1. This is the closest data point, and since it's a blue, then we would guess that this is also a blue, whatever that category is. And if I change that to 3, well, we see some changes, but essentially now I'm looking at 3 neighbors. If this is the data point still, we'd look at the 3 closest. So there's 1, 2, 3. Now notice it's not a blue anymore. It's a purple. So hopefully this makes some very general sense in terms of what we're doing here. You could, again, this could be a regression problem, though. We can use K and N for regression. Let's imagine, I'm just going to draw very quickly, very clumsily, using a mouse. I don't like this, but we'll make it happen. Let's imagine we have, oh, give me some, what would our data be? Someone toss something out.
Animal species.
So, animal species. So let's, I was thinking, I was going to switch to regression. Toss me some data that actually we measure in terms of units. So not categories, but actually, I'm just going to, I'll go.
Foreclosures.
Oh, go ahead. What one did you say there?
Foreclosures.
Ooh, foreclosures. All right. Yeah, we can do this. We can go by the cost of the payment. So the monthly payment that was involved, that's one axis. Let's call that the Y over here. But let's give it another. I'll actually draw this one in 3D. Let's, in addition, perhaps the income of the person who had the foreclosure. So one was the payment, the other was the income. And we have a graph, and yes, as the payments go up, the income goes up. These are various foreclosures that have happened. And we also want to look at, if we're measuring this, how many payments behind were they when the foreclosure happened? I'm just coming up with odd stuff. We can add a Z-axis. And I can draw these out. How many payments behind? This one's 2, this one's 3, that one's 1, 2, 4. That was very crooked. 1, 2, 1, 4, 1. You get the idea. They extend into the Z-axis. This is 3-dimensional. Now, if we had a new data point and we knew, let's say this is the new data point, we can use K nearest neighbor for regression purposes too. Let's say in this case, we're looking at 3 there. So it's a K equals 3. Well, then that means the 3 closest data points in terms of pay and income, the 3 closest would be here, here, and here, this one. Those 3, we've got a 1, we've got a 1, and this one was a 4. It looks like I was trying to draw. I'm just guessing. And so we would just take the average of those, and that would be our guess for this particular data point. Does that make sense? We don't have to draw it 3D. We can actually, we can just use a 2-dimensional, but I wanted you to see that this all applies to multi-dimensional. But we can have some variable that's measured and displayed here in the data points. And it's the same general principle, our X and Y. If we know the X, let's say we have a new data point that's here, and we want to predict what Y would be. And again, K in this case equals One, you would just take the one data point that's closest to this. So in this case, it looks like it might be this one that's closest on the x-axis. So that would be our prediction for y. This one. Right there. So this is KNN. It's a very, I love the simplicity of this thing. Honestly, I think it's really cool. It's again, we have eager algorithms where they generate a model and everything's all set and you just plug it into the model and it runs quite quickly when you need a new answer. KNN is not that. KNN is considered a lazy algorithm. You give it the training data, it's like, sure, it doesn't do anything then. When you want a new answer, it leverages the training data to give you something new. And I just find it, so you can use it for classification purposes, you can use it for regression purposes as a supervised algorithm, very powerful. And I encourage you to just play around with the simulator until you really feel like, yep, I got it. This is something I feel like conceptually I'm understanding. Now, as always, I'm gonna get out of this stuff here, clear all my drawings, get out of that. You can always refer to the documentation, scikit-learn. Here's, for instance, documentation for the regression. We'll do some examples of this in some of our next sessions, but conceptually, I wanted to introduce you to this first. This is for, again, the regression component, but there's also the classifier. And honestly, the documentation at scikit-learn is pretty marvelous. So let's do a little bit more in terms of, I just wanted to show a quick couple things. The hope is you're finding some data sets. So let's just remind you of the basics we did before. This is what we'd opened before. Let's start from scratch in this book. So actually, I'm just gonna make a new notebook. Let's start from scratch. And first and foremost, let's remember some of the stuff we used last time for importing. I'm just gonna paste it in. Just to give you something else to work with. All right, I'm not gonna use a decision tree this time. We might end up using something else. There's an Intel event. I want to expose you to the resources that are available through Intel. So we're only doing a brief bit here, but I will. Another resource, another mod, Seaborn. Very powerful visual display tool. So we'll maybe take a peek at this. Let's import some stuff. I'm not sure we'll use it. I'm just copying what we used last time. Let's get a different data set. There is a text that I actually love quite a bit. O'Reilly, you actually have access to it. Speaking of, I'm just thinking James referenced the fact that you all have access to Safari Online. Given that, I would say, go have a party and start reading through this book. It's a marvelous book. And it's O'Reilly's Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow. Second edition, not the first. Marvelous book. You can skip some of the mathy sections and not have to get in there. But that's free. That's right through O'Reilly. And in one of the pages in here, actually, I was going to reference today, page 36 in this text, it actually lists some data sources. We've talked about some other locations where we can find some good data sets. Well, yet one more option is UCI Machine Learning Repository. Now, this looks like it was built in the 80s. And eventually I will show you TensorFlow, James, but TensorFlow is down the road. You don't start with TensorFlow typically. We'll work our way up. I absolutely will show you TensorFlow though, eventually, James. So this looks like it was built in the 80s. Good news is they've got a beta version that's much improved. This seems better. This is another great source of data sets. I'm going to copy and paste this link in your chat. So put a Y in the chat if you can find your way over here and take a look around at some data sets. I'm just giving you more options. So, all right, Billy and Dal. All right, cool. Just want to make sure people are getting over there. Nick, all right, cool. Well, you can search around. You can just look at their most frequently viewed. For instance, this iris data set, very common in a lot of intro to machine learning classes to use that iris data set. We'll probably do some work with that later. I just wanted to find some quick random stuff. I came just before class. So I thought, well, let's go find something because I want you to be able to explore data too. And this turned out to be a nice little experience. I found through here, this was chord fingerings for guitar. I play guitar. I thought, oh, well, this will be an interesting data set. So let's see. First and foremost, this is what I found. Notice I'm just going to copy the link address. I'm going to put it in here. We'll end up using this. URL equals, and then I'm going to store it as a string. And Pandas makes it easy, but how is it? Import or what is it? Read CSV. There we go. So let's just try this. Let's try and read this guitar data set. If you forgot, you can go to Collaboratory. Let me find the initial link for that. Gosh, if I could type. There we go. So let me put this in the chat. Remember, we were using Collaboratory before. It's a free resource. It runs on Google stuff. It works just like other Jupyter notebooks. It's very convenient. You don't have to install anything locally. So let me return back to what I was working on. And let's see what happens when I do this. Remember, if you hit Shift Enter, it tries to run that cell. Now look, it did try to run the cell and I've got an error here. That's not acceptable. That's not what we want. Let's read it. It says parse error, tokenizing data. Something tells me something's a little funny in this data. Something's not as expected. So let's go look at this data. That's the first thing. Let's see what's going on. That's what you would do next. So I'm going to download this thing. Actually, I'll just click on it. It'll download if I do that. And let's save it. Let's look at my data. I see an issue. What do you see? If I'm importing a CSV file, what might be causing an error in this? I tell you. So Dal says it's not a CSV. How so though? What's the typical separator for a comma separated value file? Right, Nick? Semicolons will cause me issues here. They're giving me grief. This isn't working the way it is. Fortunately for us, now that I know what's going on here, I can make adjustments. I'm going to go back to my notebook up in Collaboratory, and I'm going to fix something here. We can declare the separator. And it's just as easy. You're thinking, well, what is Adam going to put here? He's just going to put a semicolon. Yep. Let's try that. Oh, that's nice. So what we see is, I'm hoping you go out and you start to explore. I really do want you to find that data set that's yours. It's going to be your baby to work on as we do some cool stuff. Some of that means you're going to try and load it, just like we've done here, and read it and put it into a data frame. And in this case, we had to do a subtle adjustment in order for this to work. Because commas are actually internal to some of the fields, so note names, A sharp, C sharp, sharp, G sharp, B sharp, F sharp, sharp. Because commas are actually within the fields, they used a separator, a different separator than normal. They used a semicolon. So now, as I look at this data set, though, there's not a whole lot I can do here. Let's rerun this up here and actually store it in a data frame that I can then describe. Oops, helps if you spell correctly. This data set in and of itself, I probably wouldn't do a whole lot without actually, you'd almost have to come at this from a natural language processing perspective. Or we'd have to do a massive amount of recoding. There are ways that we can handle this and actually try and look at some cool data. It's not a really big data set, but the point is identifying patterns. You might have some fun with it. That said, I'm going to leave this one lay. I just wanted to show you, I just went and explored a data set. I just quick did it before class. And sometimes it doesn't work right out of the box. You have to quick look at the data and say, what is preventing this from being parsed correctly? And sometimes it's as simple as just getting a semicolon set up as the separator. So any questions related to that before we look at another quick data set? Most of your time in good machine learning will be working with preparing, cleaning the data. And that doesn't stop. There's actually a movement, I've talked about it before, related to what's called Centric AI, Andrew NG's leading. And the point is you will be doing all the more work with data in the future, the hope is that you won't just stop and do all your work in models after a certain point and tweak the model. You will continuously be working with the data to make it better. That's how you can help see better performance in your models. So it starts with the basics. I want you to find some data sets, try and read them in, figure out the issues, if you have any issues, and play around with things. Let's look at another data set that I found up here. Here is heart failure clinical records data set, CSV. Let's play around with this one. So same sort of thing. Oh, I don't think I copied the link, did I? Let me grab that link. And I've got too many windows open. Disappear. There we go. So here's that link. And I'll just call it DF2. Read CSV. We'll try it without any funny, we'll see if the separator is a standard comma. Now, remember we can look at the top bunch of rows. Head normally shows a default of 5. I'm going to show 10. All right. This looks like some interesting data. So what we see is several different attributes. So age, anemia, creatinine, phosphokinase, diabetes, ejection fraction, high blood pressure. These look also like things are pretty usable at the onset. Notice it doesn't say true or false for anemia. It has a 0 or 1. Remember, we have to change values to something usable by our algorithms. We need numeric oftentimes for the work we're doing. They're already in a numeric form here. That's very convenient. So is this. So is diabetes. On or you either have diabetes or you don't. High blood pressure. You have high blood pressure, the clinical threshold of high blood pressure, or you don't. Platelets. Serum creatinine, serum sodium, sex, smoking, time, death event. This looks like an interesting data set to play around with. I could describe it as a review. Remember, this gives us just a quick overview of the general descriptive data. Count, mean, standard deviation, minimum, 25% threshold, 50%, 75% for each one of these columns. The max. I could let's see. I think let's try a different visualization. I don't know if this is going to work. I didn't try this before class. Let's do death event as the hue. I'll explain what this means if this actually works. If it doesn't work, it doesn't matter if I explain it. If it works, then I'll explain it. And size, or whoops. Oh, maybe 3. Let's try this. This might take a while. Let's see what happens. Seaborn, as I mentioned, is very nice for some powerful visualizing. You'll see in a second what I'm talking about. Or maybe more than a second. Let's see how long this takes. While this is working, I'm going to get a drink of Mountain Dew. Is anyone working along with me in the chat? Anyone trying some of this stuff too? So let's see, some of these operations take a little bit. On my local system, I think I'd be done by now. Cool, James following along, excellent. Now, we'll see what happens. It's just, it takes a while, and there's a lot of, I should have, or I say this in hindsight, I could have certainly limited the features that we were considering for this pair plot. You'll see why that would help. This is going to be pretty big, but you know, it's Google. My thought is they should be able to handle this. While this is running, I actually might show you some of the Intel stuff that I wanted to make sure you're aware of. Oh, there we go. Never mind. Here you go. That's just one command. And now we get all of these cool visuals. Are you kidding me? So again, Seaborn, let me find the website for this thing. You can read the API and you can, it's tremendously powerful. But it makes very sophisticated visualizations very easily. It facilitates your work in ways which, so does PyPlot though also, but Seaborn's just one more tool in your tool belt. And right now we're just exposing you to things. So with this data set, look at all this. Notice if I have to move my chat around so I can actually see this. Off to the right over here, it doesn't show up that well because I've got so much on the screen, but you see right here, death event. So if someone died, I'm assuming we'd have to quick look at the data to make sure label wise, but if you died, it was a 1. And if you didn't, it was a 0. That would be my quick prediction. Now we could look at the data and double check this. The point is, you can now look at all of these related to each other, age related to, or actually let's pick the bottom row so it'll be easier. Time versus age, time versus anemia, smoking versus all of these. Look at what that tells you in terms of the events. Smoking versus sex, smoking versus high blood pressure, these other types of fields. That it's more fun if there's a lot of different values. So for instance, platelets versus creatinine. Let's check platelets versus creatinine. Notice there appears to be a pattern there. One quick command gives you all of these visuals where you can then start exploring the data a bit more and then try and determine, hey, what comes next? Do I need to recode some of these columns so that I can do some more analyses? If they're all set, what models do I start to consider? So far, we've only covered a couple models. We've only covered decision trees, and KNN is what we covered today. The cool thing is you're going to get a lot of new models, and then you're going to, in your tool belt, you'll just say, what will work? What would I try first here? And you can try a couple and see which one works best. Now, I did want to get to some Intel related stuff. Let me stop sharing my screen. And I want to show you what's going on at Intel right now. There's a big event where you can actually see lots of really neat things. I need to open my email for this though. One sec. Because I wasn't thinking, I forgot the link. So let me copy this link address. Let me paste it in the chat here. Intel is who we're collaborating with to build our new AI certificate and hopefully an AI associate's degree. We're still getting the approval on the associates. But Intel has done a lot of legwork to prepare some pretty fantastic materials related, specifically focused on I'm going to share my screen on community colleges. So let me share my screen and show you the event they have going on right now. I'm going to share sound just in case there is sound, and I'm going to optimize for video clip just in case. So click here to join. Hopefully you're all visiting this. Oh, whoa. Look at walking in. I could skip this, but you know, it seems cool. I'll play the game. Let me bring open my chat. Are any of you at this event right now? They call it an event, but essentially it's a set of virtual offerings. So Nick's there. Anyone else? I hope you'll take a peek at it. So Nvidia's, okay, cool. There are several different things you can explore. So for instance, here are some speakers who give a quick talk. Matt, you're in, you think, good. Notice though, across the top, it's probably a little bit easier. I've noticed that you can go through here, but it's easy to miss things. Celebrate, learn, lobby, compete, badges, selfie booth. Intel's trying to raise awareness related to AI capabilities and offerings. What's happened in the field so far is it's been very top level focused in terms like PhDs and people with master's degrees are getting hired to do stuff, but there's more and more work that needs people with a technical background. For instance, the pipelines that are used to process a lot of large AI related tasks, machine learning, it's good to have, you don't want to be paying PhDs to do a lot of this work, working with the data. There are jobs that are coming into market now that are focused on people with technical skills. And Intel's trying to raise this awareness. That's part of what's going on with this particular festival. Notice, though, that it's quite broad. It's focused on AI in general, but that is one facet. So let me point you to some, now that we're here, I hope that on your own time, you will explore this. There are cool things in here. They point to some training. Let me just quick go into learning here. So I head into learning. I almost hit that person. And notice AI impact talks, demystify AI and Openvino, AI ideation skills workshop. You have resources here that you can explore. Now, Intel is big on edge AI. So I'm at a new page here. I just want you to see there's the event, but there's also what they have on their public website. They are big into edge. And when we talk about edge AI, who has a guess? What's that mean?
All the metadata they gather from their browser.
So that's a good guess. when we talk about the edge, typically when you think of AI right now, often where you go is you think about the cloud and these huge servers that are processing vast amounts of data, and everything's happening on these systems that are the size of rooms, really big. We've got racks with tons of servers on them and everything's happening there. When you think about the edge, sure, there's still the cloud here that can be leveraged. That's the worst cloud ever. You can NFT that. I give my students so much money just by letting you NFT my stuff. So sure, we have the cloud, but what about what's running locally in someone's house on some little unit that's perhaps just measuring their thermostat? Or what about some out in a business that's actually trying to monitor the pedestrians that are walking by and the foot traffic by their stores? Out here, these types of offerings, we think about the edge. We think about little, for instance, let me show you rather than talk about it now. We think about, well, who's heard of an FPGA? Anyone know what that means? Anyone from my electronics course? Oh, hey, there we go, Matt. Field programmable gate array. Yes. These are hardware. You can actually program the computer, so you're actually changing the behavior of the hardware itself. It's pretty slick. It's very performant. And because it's so performant, it's something that if you actually take the time to build a field programmable gate array, you can see that there's a very nice, efficient, low power option for handling AI related tasks at the edge. Remember, we're talking about not in the data center, not up in the cloud, out in the field. Intel actually has this offering open. I'm going to jump to a different page here. Openvino Toolkit overview. I'm going to put this link in the chat. I'm exposing you to this because when you're actually at that Intel event later, hopefully you're exploring all this week. It's up for the next week or so. I hope when you're exploring, you're at least somewhat familiar with generally what Intel's talking about here. So Openvino, look, let me jump down here. They have a set of steps that they outline for getting AI related work done. Here's a particular workflow that they're advocating. So planning, setup, determine configuration, determine the model, select a model, find or train a model. Is the model accurate enough? Try, retrain, try some other models, run the model optimizer, run inference engine. Was it fast enough? Integrate model pipeline, package for deployment, deploy app. Here, when we deploy, often what Intel's thinking about, sorry, I got to move my, that way I can actually look at this. This is one of their other offerings, a neural stick. Plug and play development kit for AI inferencing. So build and scale with exceptional performance per watt, per dollar. You can use Mac or Windows, and it doesn't need cloud dependence. This AI can run locally on this dinky little stick. Notice, here's what it says down below for something I would bring to light. This plays nicely with Raspberry Pis. Who's played with a Raspberry Pi device? You can just plug this thing in, and this is built to handle the AI that's running at the edge. So when you're at this Intel event that we here it is. Here's the AI Global. You're going to see these types of things that Intel's trying to bring out. And I just want you to know that's the context. They've actually put together curriculum for community colleges. LCC is going to have a certificate that's related to that within the next year. I'm working on it right now. And the hope is to have an associate's. And they're doing this because they see a need, and actually the rest of the industry sees a need for more technical education related to AI. There's too much work to be done to be paying PhDs to do everything. Your PhDs will be your boss, but they need people, just as you need, architects, software architects to be the bosses of programmers. We need the PhDs out there to be the bosses of people who are trained in AI, machine learning, who can actually get stuff done. And so this is a lot of what you'll see at this event. I hope you'll explore it. The competing's already been done, so I don't think you I'll go back to learn. That's nice. Let me do that. So I hope you'll explore, though. See what's out there, social wall, social media. You get connected with people. If you're interested in this and you want to work in this sector eventually, getting connected is a good thing too. But I want you to be aware of this. I want you to explore it during the week. One other thing I want to bring to your attention. Now, or actually, I guess it's two. I've been focused on, as we've shown here so far, let me actually get rid of the annotations I've got up there. We don't need these. We've been leveraging Python so far for some quick examples. And for notebook purposes, I like Python, and also LCC students have exposure to Python. Typically, that's one of the courses you take here for the CIT department. However, I don't want you to think this is your only option. Another option, let me grab the book. I've got a few books. Let me stop sharing. Have any of you heard of R? So Dell has, Nick has, Matt has. Very nice. R is a very productive, I'll call it an environment for statistical work. And it's become quite powerful for machine learning too. Most of the stuff I see related to R comes from the direction of data science, which is closely related to machine learning, AI, and data analytics. But I don't want you to think Python's the only route. Additionally, I want you to see, because part of the club is exposing you to things and then letting you explore. Let me share my screen one more time here. And let me, what was that? Oh, there we go. Azure actually has a pretty slick, let me put this in our chat. Let me share the link here so you can go take a peek at this. Maybe some of you are thinking, you know what, I keep seeing this Python, and Python's not my thing. I'd rather just do things, work with data. And I'm not a programmer first. I do a little bit of coding, but that's not who I really aspire to be. You don't have to. As you can see here, you can build models and work with data, clean the data, prepare the data, all by using a visual interface. You get a free account. You sign up. We might, if I'm going to ask you to vote and decide what we do next. But this is one option. We could all sign up for accounts and we could spend a session working through this. So I just want you to know, I know many of you feel very good in the realm of Python and programming in general. That's excellent. But maybe some people don't, but they're still interested in AI related principles, machine learning. So that's our quick, I covered a lot of stuff today because there's a lot going on. I just wanted to expose you to several things. What would you like to do moving forward? We have time here to vote. What would you like us to explore? So far we've looked at decision trees, KNN. We've used notebooks using Collaboratory to explore data and run some basic models with the decision trees. You have the Intel related event link that you can explore this week just to look around and see related to Intel's offerings. And we've also looked at the idea that you can use other tools like R, or you can use visual tools like Azure Machine Learning Designer to build models without actually using any code. What would everyone in the group like to do next? And it doesn't have to be something we've looked at in the past few minutes here, but I'm just trying to expose initially and see. So I have a vote for R from Untitled. Who else? Let's hear some more feedback. So I see another vote from Matt for R. There's some more people in here. Let me see more votes. And we can do. James, I like James' phrasing. I'm not mad at learning R. That's that. I like it. I like it. So, and Billy says, no preference. I want to learn everything. And Matt, that's my attitude. All right. So let me give you two options and then we can, if we do R, some work with R, you're going to have to install that locally, typically. Everyone have a computer where you can install, well, actually, Anaconda might be the easiest thing. Because it comes with RStudio 2 typically. So NVIDIA has Anaconda. I'll paste this in. If you're looking at products, the individual open source version is free. And here are some of the things it includes. But one of the things you'll see in here, R is right there. This is probably the easiest way to get it installed. The one thing about this is just making sure everyone could get this installed and work along together. Let me take a quick peek. I'm going to look up Collaboratory and just see. We do have some online options, but I think it would probably, for R, it might be easier to have it locally. So, all right, let's have a component of our next class be a little bit of R, just so you see some of the differences. R is going to feel very different to those of you who are more who are coming from a programming background, the R language is set up to make things easy for people coming from a stats world to get work done. Whereas the Python tools we've been using were set up to be easy to use if you were coming from a programming perspective. So they're different in terms of who they were initially appealing to, and you'll see that reflected in the choices that are made. So I think it's a good exposure, and then you can vote again in terms of how to move forward. Do you want to go back to more of the collaboratory? What I'll probably do is I'll probably split it then. We'll do an introduction to R, and maybe we'll do one model in KNN with a new data set. We'll try one new model or maybe two new models. Does that sound like a plan for next time? All right. I hope you explore the Intel related event just to see what Intel's got out there. There's so much going on in the AI world right now. Intel is one of the players you want to be keeping up on. And also, I don't know who noticed, but Apple's new M1 processors, the neural processors that are actually included with those, that's incredible to me that that much sophistication is built right into those chips. It's incredible. So, you know, if any of you buy those, don't tell me, I'll be envious. I got to save up. Thank you everyone for coming. It's about 12:30. I hope you enjoyed just learning a little bit. Hopefully you learned a little bit more. I'll put the recording up so everyone can watch. And additionally, I hope you explore the Intel event. It's a cool thing to see. Oh, and Matt's wants to point out an event Thursday called Startup Grind Lansing. Link to sign up is here. Come check it out. And yes, thank you, Anvita. Bye, everyone. I don't see the link, Matt. Can you post that again?
I'm trying to find the tab that I had open that actually has the link.
No problem. I'll stop
Oh,
recording.
here it is.